Okay, workbook, page 161, question 4. Workbook. Then, you sit here so long, come here, talk to presenter, never take your workbook. Okay. Oi. Then your workbook close for who? Yeah. Can you all be like Akil? Be like Akil. You got accident. What happened? Your pants torn. Then go back, then make it patch up. Presenter, what about your workbook? Huh? Okay. Hello, Cyrus.
What do you need me again?
Ah.
What do you need from me now?
I need your ear. Your ear can write things. Okay. Okay, well done. Okay, the very important thing that I told you all to take note, the naming of the triangle when they tell you the congruency, Leila, Ines. Very important, the naming will tell you which point corresponds to which point. Inside the triangle, which is the corresponding point, you can tell from the naming. 161. Hello, got pay attention or not? Cyrus, got pay attention or not? A corresponds to A, then the B in ABC corresponds to the D in ADE. C corresponds to E. Okay? Okay. Because if you don't look at the naming, sometimes you may not know exactly which point corresponds to which point. So A corresponds to A, B corresponds to D, C corresponds to E. So it is actually like a mirror one. They are congruent, but it is like a mirror like that. Okay. Other than knowing the points, the side also, you can tell from the naming. AC is between first letter and third letter, means AC corresponds to first letter, third letter, AE. So just from the naming, you can know that AC is the corresponding side of AE. Okay? So if they are congruent, then AC corresponds to AE. That means they have the same length. So AE is also equals to 6 cm. By knowing their congruency, you can know that AC same as AE, so it must be 6 cm. They ask you to find the length of CD, so you must be able to link CD to the entire AD. Okay? If I want to know CD, I take AD minus AC, I can find CD. So what is AD? Then I see AD is between first and second letter. AD must correspond to AB. Okay? AD corresponds to AB. So AD is equals to 13 cm. If AD is 13, then you will be able to find CD. CD equals to AD minus 6, so equals to 7. Okay. The mathematical name given to ABD. Yes, David, what is the mathematical name given to ABD? Yes, isosceles triangle. Okay? Because in this triangle, AD has the same length as AB. So it must be an isosceles triangle. Go. Okay. Hey, the rest of you don't need to keep getting distracted because Lexus tore his pants. Okay. Hello, hey, today why everyone keep talking?
Hey, go wear pants inside. No! Hey, wait, please. Hey, later upskill you. Coach, you don't have your coffee, you talk.
Okay, in the diagram, ABX similar to DCX. Again, the naming is important. From the naming, you must know ABX, then DCX. That means A is the corresponding angle or corner of D. B corresponds to C. X is the similar point. Okay? So it doesn't mean A on the same side as C, then they are the corresponding side. Hey, Dylan, Luis, you all don't sit together better. You all talking, I talking, who listen? Then I have to raise my voice. Okay, so from the naming, you must be able to tell A corresponds to D, B corresponds to C. X is the common point. AB is 5 cm. AB is between the first and second letter. So on the bigger triangle, AB will correspond to first and second letter DC. Meaning AB and DC, they will give you the scale factor because they correspond to each other. Okay? So if I want to find CX is in the big triangle, it is between the second and third letter, so it will correspond to BX in the small triangle, between the second and the third. Okay? CX in the big triangle, it is the second and third letter, so it corresponds to BX in the smaller triangle, also second and third. Okay? So if we look, that means CX corresponds to these four. So if they correspond to each other, means if I divide CX by 4, it will also give me the scale factor. So the scale factor of CX over BX must be the same as CD over AB. because they are similar triangle, all the sides, all the corresponding sides will give you the same scale factor. So when I want to find CX, I put CX over the corresponding side, which is BX. This will give me the scale factor, but at the same time, I have a known pair. The pair that I know is AB and DC. Okay? So when I take DC over AB, it will give me the same scale factor. Then when I put in all the values that I know, CX I don't know, BX is 4, DC is 17.5, AB is 5. Then I can solve this equation, make CX the subject, multiply 4 to both sides. Then I will be able to find CX is 14. Okay? AX. Then I must also know AX corresponds to which one. Then I see AX, first and third. So AX corresponds to first and third DX. So AX corresponds to DX. So same one. If I put AX over DX, this time I put the small one over the big one. Then with the known pair, I must also put the small one over the big one. Then when I find AX, I just multiply DX to the other side. Don't have. I never bring money out. But I can pay now. Yeah. Buy what? Why you need to buy pens now? No. It's not so important . Why you cannot wear these pants? Then you wear his PE pants . Then he wear the long pants . PE pants stretchable . Cannot fit meh? Oh. 40 . Okay. State the relationship between AB and CD. So this one is something extra, but something that you all need to know. Next time you will see this very common one. When this angle XCD corresponds to XBA. This angle, they are the same. And this angle also same as this angle because they correspond to each other. Okay? Hello? What can you say about this line? Or this line? Okay. Yes. There is a Z and these two angles are the same. When will this happen? When will these two angles be the same? It will only be the same when these two straight lines are parallel. AB parallel to CD. That's why they form this Z shape, which will give you the same angle. They give you the alternate angle being the same. So it's because AB parallel to CD. Okay? The vice versa is true. Meaning, if they tell you you have a shape like that, and then these two straight lines are parallel, then these two triangles will always be similar. Because the angle in between is the same, opposite angle, and this angle always the same, alternate angle, this angle and this angle always the same. So when you see parallel line, they draw two triangles like that, it also means these two always will be similar. Okay? That is the reverse of this question. Okay, question 6. Okay, this question is actually express question. They want you to say, or they want you to understand, why is the triangle DBC similar to BAC? Sorry, ABDBCD. Then, why? Why are they similar? When are two triangles similar? Cyrus, when are two triangles similar? When are two triangles similar? No. Got right angle also can be not similar, what? Right angle. This one also right angle. Are they similar? No. So when are two triangles similar? When it look the same. Correct. But why will they look the same? No. No. Hey, this one go back to the very first thing I tell you about similarity and congruence. When they are similar, Ryan? Similar, don't need to be same size, but they must have the same. Start with S. What is the word?
Size. No, it's not size.
I just told you not size. Congruent, then same size.
Similarity. Shape.
Yes.
What are we? Same similarity. Same shape.
Okay, it is back to... Hello. It is back to same shape. Okay, both similar, congruent have same shape. Congruent must have the extra condition, same size. Similar can be different size. Okay, one more thing. One more thing. Chrysander. Okay, when do we say two triangles have the same shape? Let's say I have a equilateral triangle. I have a bigger equilateral triangle. They are both equilateral triangle. Can I say they have the same shape? Leila say yes. David?
Same shape, same angle.
Yes, Okay. So when two triangles have the same shape, if now I tell you the equilateral triangle means all 60 degrees. Okay. Equilateral triangle means all angles are 60. But now, if I change, one becomes 70, one becomes 60, one becomes 80. Do I still say they have the same shape? No. Okay. So, what can I say about having same shape and the angles? The what? Yeah. So when the angles are different, they no longer have the same shape. So for a triangle to have the same shape, all the corresponding angles must be the same. Okay? Let me give you another example. Just now, Cyrus said right angle triangle. So if I have a 90 degree, I have a 30 degree, I have a 60 degree. Then I have another triangle, 90, 30, 60. Can I say they have the same shape? Yes, because the 90 corresponds to the 90, 30 corresponds to 30, 60 corresponds to 60. They still have the same shape. Okay? So no matter how I place this right angle triangle, as long as there is a 90, 30, 60, all these three triangles, I can say they are similar because they have the same shape. So when all the corresponding angles are the same, they have the same shape. Okay? Okay. So this one extra one, we have a 90 degrees here. We have a 90 degrees here. Okay? Now I have this common angle C. This C inside the right angle triangle BCD. Then I compare it to the right angle triangle ABC. There are now two right angle triangles. Can you see that this 90 degrees is at the D? This angle C is the same with both. The big one, the angle B is 90 degrees. The big one and the small one, they are both C. The angle is both C. And in the triangle, if I know this is 90, this is C, definitely this angle A must be 180 minus 90 minus C. Then for my angle B, it is also 180 minus 90 minus C. So actually angle A and angle B, they are the same. Can tell or not? Or not listening? Angle D in the small one is a 90 degree. Angle B in the big one is a 90 degree. C is the same. In the small one is also angle C. In the big one it is also angle C. When I call this angle C. Then in a triangle, angle A now is equals to 180 minus 90 minus C. Angle B is also 180 minus 90 minus C. So angle A and angle B, they also are the same. Okay? Meaning, this angle is the same as this angle. So can you see that actually in these two right angle triangle, all their three angles are the same. So actually I can say angle, let us start with the big one. I can say that the triangle ABC is congruent to triangle BDC. Because their angles are all the same. And then C corresponds to C. A corresponds to B here in the small one. And the 90 degrees is at B, at the big one. And is at 90 degrees at the D, at the small one. Okay? Okay, but this one is express. Then they will ask you. Usually they wouldn't ask you like that. Can? Okay, then we can skip this question. Okay, your practice. Question 8. Okay, never mind. Question 8 we do together. They want us to express x in terms of y. Go. So we want to be able to link what is x to what is y. Okay? Then when we look at these two triangles, where are the corresponding sides? ABC, PQR. So AB corresponds to PQ. Okay? BC corresponds to QR. They purposely never draw them in the same way or same manner, but you must know, because you can read from the naming. AC corresponds to PR. Okay? So A corresponds to P. You can write this to help yourself see. B corresponds to Q. C corresponds to R. Express X in terms of Y. So what is the relationship between QR and the bigger triangle? QR corresponds to BC. So I can say X over Y is going to give me a scale factor. Then I also know PR and AC. So are they related? PR is also the same as AC. So X over Y, small one over big one, then I might also take small one over big one. So it's equals to PR over AC. So X over Y is equals to 9 over 18. Then, when I make X the subject, express X in terms of Y means making X the subject. X is equals to Y multiply 9 over 18, or X equals to half Y. Lexus, where's your book? Okay. Part 2. Express QP in terms of y. QP is here. So how can I link it to y? I cannot link it to y, but I can link it to x. And there is a missing information that they want you to fill in yourself. The angle B is 90 degrees, meaning the angle Q here is actually 90 degrees. Because angle Q corresponds to angle B, this one is actually 90 degrees. Then how can I link QP with X? I have a right angle triangle. I want to link QP to 9 to X. I can link them through Pythagoras theorem. Pythagoras theorem is the relationship between the three sides of a right angle triangle. So if I use Pythagoras theorem, by Pythagoras theorem, the longest side square, thus the longest side is 9. 9 square is equals to x square plus qp square. Okay? Then just now I found already, x is actually equals to half of y. So I can substitute my x as half of y. So if I square, then it will become 81 equals to 1/4 y square plus qp square. Then I want express qp in terms of y, means I want to make qp the subject. Okay? So I will put qp on one side, bring everything else to the other side. Then I switch the left and the right, meaning qp square I write on the left hand side. Then 81 minus 1/4 y square I write it on the right hand side. Then finally, I want to know what is qp. I take square root on both sides. Answer. Cyrus, you using your magic again. The year can write things on. Okay, Ken? Okay, then your turn. Practice. Try question 9. Haven't yet. Try question 9. Try question 9.
Next station. What was that?
Why got this sound? Ah? Chrysander, are you all doing question 9?
Next question. Why you draw like that? Cookies.
Where did that sound come from?
Find out.
Speakers. Must ask the PA people. Oh, Lexus. Were you listening just now? How do you tell which side corresponds to which side? Huh? Uh-huh. Uh-huh. Why?
Hey, class, listen to me, class. Let's go. Yes. Because you know this one is similar. Means the angle will change. You just find what DAB is similar to. Yes, DAB is equal to what? Find what is similar to. Just find it.
Okay, question 9, they test you on all your basics. AB corresponds to PQ. Okay, then the pair that can give me the scale factor is AD with, also no battery already, AD with PS. So if I want to find AB, I put AB small 1 over big 1. The known pair is small 1 over big 1. Hey, finish, try question 10. Length of AC. Where got difficult?
Just take 24
Ya lah, same lah. I write like that look more pro. I naturally look pro. Okay, Ken, everyone should be able to get all these. Pythagoras theorem, the last one. Yeah. I will still see you all tomorrow, right? Yeah. Okay, if you can go and look through the SLS video, then tomorrow we start construction of bisectors. Very easy one. Bring your compasses. Okay? What's the compass? Compass view. Your compass is the one side needle, one side pencil one. Okay, bring your compasses. Your compass, bring. Okay, bring your compasses tomorrow. Okay, thank you class. Thank you. Bye bye.